Hi students, today we're going to go through just one part of this chapter, right? Mass and weight, whereas you will do density on your own during home-based learning, all right, next week. Okay, so without further ado, um, let's start. All right, we are going to go through only mass and weight. Okay, after going through this lesson, I will need you to fill up the worksheet found on Ask and Learn. All right, let's continue. Alright, so for this session, we will need to learn a few things. Basically, what is mass, what is gravitational field, and what is gravitational field strength. Alright, next we will learn what's the difference between mass and weight. Alright, we will often confuse ourselves with both. And lastly, how do we find the weight using the mass and the gravitational field strength? Okay, now let's recall. Now, weight is a gravitational force exerted by Earth on the object. Okay, I went through with you guys before that gravity always acts towards the center of the Earth. Okay, so if you are standing here, right, you are always pulled down by gravity towards the center of the Earth. So gravity is actually a force exerted by the Earth on the object, right? Be it a human or a ball or a box, it doesn't matter. It always acts towards the center of the Earth. Moving on. Now, weight is a vector. Alright, I hope you remember what is a vector. Vector is a quantity with both direction and magnitude. Alright, so direction is important because we know that the weight always acts downwards. Alright, it cannot act anywhere else. It always must act downwards. Alright, as shown in the example here. Now, so what is mass? How is it different from weight? And what is gravitational field and gravitational field strength? Now, what is mass? Now, mass is the amount of matter in a body. Alright, we know that every object is made of atoms, molecules, things like that. So mass is exactly how much of this matter is in the body. Alright, and the SI unit for mass, as we learned in chapter 1, is kilogram. Alright, any other units is not SI unit. So, what is weight? Okay, like what we said just now, the weight of an object is the gravitational force acting on the object. Alright, if there's no gravity, there is no weight. If there's no mass, obviously there's no weight. Now, the SI unit for weight is Newton. I think we already um, use this uh, use this uh, use this unit quite often. Okay, in the chapter on force. Right now, so what is gravitational field? Now, gravitational field is a region in which a mass experiences a force due to gravitational attraction. Meaning to say, right, if I put an object here, alright, it will fall to the center of the Earth because it falls within this area called the gravitational field. Alright, now if I put it here, it will still fall in because it is still within this area. Okay, if I put it very far away, like here, it is out of the area. It's out of the gravitational field. It will not experience a force. Okay, I hope you understand what I'm trying to say. So I repeat, okay, a gravitational field is the region, which is a shaded area, in which a mass will experience a force due to gravity. Now, when a mass is placed in the gravitational field, it experiences a gravitational force. When it is placed outside, it does not. Okay, so if I go to write, I hope it's clear enough. Let's move on. Now, this gravitational force is also known as the weight. Right? So this is a simple term for gravitational force. Alright, now I hope you now have already realized that the gravitational force always acts towards the center of the Earth. Okay, like in the previous example, whatever object you have, it always acts to the center of the Earth. Alright. So, what is the Earth's gravitational field? Okay, as we said just now, a gravitational field is the region in which the mass will experience a gravitational force. Alright, now the strength of this field is strongest at the surface and gets weaker further away. Okay, which means to say, okay, let me remove this first. Alright, which means to say if I place an object here as compared to here, position 1 and 2. Alright, position 1, the field strength is stronger than here. Okay, as you go further and further away, it gets weaker and weaker and weaker until a point in time when it does not experience any more gravitational force. Alright, so let's say a 50 Newton object placed here and a 50 Newton object placed here. Obviously, this will experience more gravitational force because it is closer to the Earth. Okay, so what is gravitational field strength? Sorry. Okay, we know that gravitational field is again the area around the Earth. Okay. So what is gravitational field strength? Okay, the field strength is defined as the force acting per unit mass. Okay, in general, it just means how strong the force is. Okay, now gravitational field strength defined as the gravitational force acting per unit mass. Force per unit mass. Okay, if you remember this, I hope you know what this is, F over m. Okay, take maybe 10 seconds to recall what is F over m as we have done in chapter 3. Alright, I hope you have the answer now. It is A, and A is also called the acceleration due to gravity or free fall. Okay, moving on. Now, it tells us how strong the field is or the force is. On Earth, the gravitational field strength is about 10. That means A is about 10. Okay, 10 meters per second square or 10 newtons per kilogram. The same because A is F over m, this is Newton, and this is kilogram. Alright, I hope you are able to understand. If you are not able to understand, you may see me or you may just go back, okay, to listen it to again. Alright, so note this unit is dimensionally the same as this. Okay, alright, because in chapter 2 we know that A has a unit of meters per second square. But now A is F over m, where F is my newtons, m is my kilogram. Therefore, acceleration is also Newton per kilogram. Okay, by definition of the Newton, it can be written as kilometer per second square. So what I say is basically this and these are the same. Alright, so newtons can also be written as okay, so this and these are the same. Alright, but you don't have to know this. I mean, you just need to know that these two units are the same. Alright. Okay, now mass versus weight. Now there are a few fundamental differences between the two. Mass is the amount of matter in a body, whereas weight is a force acting towards the center of the Earth. Alright, mass is a scalar quantity. Okay, there's no direction involved. Weight is a vector quantity because weight is depends very much on the direction. SI unit kilogram, SI unit newtons. Okay, mass is independent of the gravitational field strength, meaning to say wherever you put the object around the Earth, okay, it does not matter whether the mass, or rather I would say the mass does not affect anything. Right, it's independent. Whereas weight is dependent. Alright, the nearer you are, the more weight. The further away you are, less weight. So I'll write nearer, more weight, further, less weight. Alright. Okay, so how are mass and weight related? Alright, now the weight or amount of gravitational force acting is dependent on its mass. Okay, we know that this in chapter 3. Okay, I will just jump away, or rather I will just go straight to show you this, that W equals to mg. W is my weight, m is my mass, g is a constant. It's called the gravitational field strength. On Earth is 10. Alright, let's go to see some practical examples. Okay, now I want you to read this on your own. Okay, how to measure mass and weight. Alright, so let's look at some examples. The weight of 1 kilogram is measured at A, B, C, D, E. At which point will the weight be the smallest? Okay, take 10 seconds to think. Where will the weight be the smallest? Alright, I hope you have come to the answer. I hope you understand that the further away the object, the lesser the weight. Alright, so the weight will be the least here. At which points are the weight approximately the same? Alright, so basically there are actually two pairs. A and E are approximately the same. They are the same distance away. And C and B. Alright, so move on. Okay, now the next part on inertia, I want you, okay, to look at it yourself from the textbook. Okay, we have already gone through inertia. Okay, you also know that it's called a lazy law, but please don't use this in exam. Lazy law is a very slack term to use. So can you please read up on inertia from your textbook? Alright, then fill up level 1 of the worksheet on Ask and Learn. Okay, I want you to bring this paper back on Thursday. This Thursday. Alright, thank you.